That's true. These are facts. However, last week.
Okay, let's start. Sorry about the football team. What? Snowed? Oh, did it?
Yeah.
Okay, so here's the plan. So we're going to do inverse sine, and you have homework due for that Wednesday, and that is on the exam Friday. We'll continue that Wednesday. So our third exam is this Friday and Monday. So I posted a review outline, and then you got all the web work is still open. So that's a really good way to study, is going through all the web work, and then of course the videos. So you got lots of, and then everything in the workbook too that we've done. So there's plenty of material for you to study. Use that outline kind of as the centerpiece of your studying to guide you towards problems to find and do. Okay, so I want you to just get your calculator out. So we're going to talk about inverse sine. So just get your calculator out. And set it on radians. So go mode, and the third one down. Make sure it's on radians. And then I want you to go back to the main screen, and then I want you to put in sine of 2. So sine of 2. And so what'd you get? What's the meaning of that number? What is 0.909? Tell the person next to you. What's the meaning of that number, 0.909? You should all know that. And for that matter, what's the meaning of the 2? What's the meaning of the 2? And what's the meaning of the 0.909? Why do they make sense? Okay, so sine of 2. Oh, 09. It's all right. Okay, so what are we talking about here? Let's see. How about I just can't decide. Okay, Sean in the back. What's the 2 mean? What are we talking about when we put sine of 2? What's the 2? What's that? Degrees. It's the sine of 2 degrees. Is that what we're talking about? No, I told you to put your calculator on radians. Tyler. What's that? Okay, angle measure of 2 radians. What point on the circle is that about? Angle measure of 2 radians. Here? Someone tell me, where is the angle measure of 2 radians? Sebastian. Gotta know this if we're in Module 7. Gotta know this.
Should be in the, just in the beginning of the second quadrant.
He wants just in the beginning of the second quadrant. Yep, because a radian comes from how many radius lengths are swept out by the angle, right? How many radius lengths are cut off by the rays, right? Cut off by the rays. And so why does it make sense that the sine of 2 is 0.909? I know Danny knows. Sean, number 2. Why does it make sense that the sine of 2 is 0.909? Sine is the y value. But what's the meaning of 0.909? Yeah, that's true, but what's the meaning of 0.909? Why is it 0.909?
It's 9/10 of the radius.
9/10 of the radius. Where? 9/10 of the radius
Toward,
above the horizontal diameter, right? So we're almost 1 full radius length, or about 9/10 of the radius length up above the full diameter. Okay, so now put in second sine, which is the inverse sine of 0.909. What are you going to get? You're going to get 2, right? What'd you get? You didn't get 2. So what we're going to talk about today, so when you're using arc sine, inverse sine, it's not so simple as, well, we should have gotten 2. So you got to know what's going on with this. When you're doing problems in context and you're using arc sine in the calculator, it's not as just simple as, well, the sine of 2, then the sine of 2 is 0.909, and the arc sine of 0.909 is 2. Okay, so we're going to kind of uncover what's going on here. You really have to understand in order to solve problems. Okay, so what would the meaning of the reverse process be? So we talked about the input and output of f, which we all know by down like the back of our hand. What's the input of sine? Alex back there, what's the input of sine? Which angle in radians? No, just any. So just in general, the input of the sine is what? I know that. I know Matt knows. Colton, what's the input into sine? We hammered it day after day after day after day. Everyone in here should know. Nick, what's the input into sine? Thank you. Measure the angle. So counterclockwise from the 3 o'clock position. It's the input into sine. What's the output? Harlan.
It's the vertical distance above the horizontal diameter measured in a fraction of the radius.
Yeah, well said. You said it perfectly. Vertical distance measured above the horizontal diameter, fraction of a radius. So what would the reverse process be? What would the input be? The reverse process. Vertical distance above the horizontal diameter measured in fraction of a radius. Output would be measure the angle, so counterclockwise. Okay, so we're reversing the process. So now the input of the reverse process is vertical distance in fraction of a radius length. The output will be the angle measured counterclockwise from the 3 o'clock position. Okay, so there it is. Okay, so here we go. So here's some, while I start taking attendance, here's some practice of that. So the inverse notation, remember, f, that's not an exponent. That means the reverse process of f. The reverse process of f. So I want you to, with the person next to you, think about these. Don't use your calculator. This is not about your calculator. Put your calculators away now. So based on, you filled out the whole unit circle for your last quiz. And so that was so that you would know those key angles. So based on that and based on these meanings for input and output of the reverse process of sine, make sense of these 4 expressions right here. Okay, go. Okay. What's the meaning of f inverse of 1? The meaning of that. What is the meaning of that? Let's see here. What do you think? Yeah, Jed?
F inverse of 1 means that when the measure of, when the vertical distance above the horizontal diameter is 1,
Okay.
it's the measure of the angles that count clockwise.
He's saying that right thing means the measure of an angle. That thing is meaning the measure of a certain angle. Agree with that? Yep. And which angle is it? When?
500 feet.
Yeah, so it's the measure of the angle corresponding to a vertical distance above the horizontal diameter of 1. So let me show that here. It's kind of like looking at that, right? Like y equals 1. And so what angle is that? Okay. Agree? 5 or 2? All right, what's f inverse of 0? What does it mean? First of all, what does it mean? Aiden, what does f inverse of 0 mean? Measure of an angle. Good. It's the measure of the angle when we're 0 radius lengths above the horizontal diameter. So something like, wrong thing. This is what I want. Like that. So here we are. The input is 0. So we're talking about at the horizontal diameter. And what measure? What angle is that? 0. Oh, he said more than 1. So he said 0. He said pi, and he said 2 pi. What do you think? Is he right? Yeah, more than one angle get us that vertical distance, 0, and then over here at the 9 o'clock position, when the angle is pi, and then all the way back again at 2 pi. Any more? Any more angles? That will get you to the 4 pi. What about clockwise angles? What about going clockwise? What would that be? Negative pi. How many angles are there? As many as you want, right? So there's as many angles as you want, because we can keep going around past 2 pi, keep rotating, more and more openness, right? More and more openness. Every time you hit a multiple of pi or negative pi, you're going to be at the 0 fraction of a radius above the horizontal diameter. Okay, what about negative 1/2? Here we are at negative 1/2. What does that expression mean? How about Jose? F inverse of negative 1/2. What does it mean?
It's the measure of the angle we are negative 1/2 radius lengths below the horizontal diameter.
Okay, fraction of a radius, right. And so what angle, do you remember what angle from your unit circle? Without your calculator. This is why we did the 16 key angles. Pi over 6? Pi over 6 is here. So remember, so this is going to be one of our pi over 6 angles, right? So just count, ready? So the reason I gave you that method was if you don't memorize it, you could still just figure it out on the fly, right? So count. 1, 2, 3, 4, 5, 6, 7 pi over 6, 8, 9, 10, 11 pi over 6. Remember that? Okay, how about this last one? The f inverse of pi. Lexi, what do you think? What's this about? What does this mean? The vertical distance in what unit of measure? In radius length is pi. or about 3.14. And the whole thing means, that whole thing means what? Right. So we want the output is the measure of the angle, so counterclockwise, that will give us, that will put us, what, 3.14 radius length above the horizontal diameter. So what angle is that? What's that? It's not there. Why not? Only goes to 1. Right, exactly. So what's the most number of radius lengths you can be above the horizontal diameter? 1. So this is saying, kind of, it's like off the screen up here. It's like up at the ceiling. It's like saying what angle measure will put us at 3 radius lengths above the horizontal diameter. And she says, ain't happening, right? She's right. Does not exist. That's what you should have had for that one. What are the possible inputs then into the inverse sine? What are the possible values that are legitimate inputs? Christopher? -1 to 1, right? Because we're talking about fraction of a radius length. We can go down to -1. That's the lowest we could be, or up to 1. So anything outside of -1 to 1 doesn't make sense to go into the inverse process, right? Okay, so so this inverse process, is it a function? So what do we have? For this we had 0, pi, 2 pi. This one we had 7 pi over 6, 11 pi over 6. Is the inverse process a function? Remember what the definition of a function was? Is it a function?
No.
Why not? So why is it not a function? Okay, so for a given input, we're getting more than one output. Remember what a function is? Think about a phone, a functioning phone. When you put a number in, what do you want to happen? You want it to call a certain person or place every single time. You don't want it to end up calling the pizza place sometimes and your mom and the credit card company the same number, right? Every time you put the same number in, you want to get connected to the same person or place. That's what a function is. So here, we're putting a number in. Sometimes we might get 0. Other times pi, 2 pi. All those are possible outputs. So the way we're thinking of it so far, it's not a function because we're getting multiple outputs for the same input. So, but when you put it in your calculator, you put arc sine of 0.909, you got this number, 1.14. And every single time you put 0.909 in your calculator, you're going to get 1.14 every single time. So your calculator is acting like, yeah, it is a function. Okay? So we need to do something special in order to kind of make a function out of this. Because the way we're thinking of it now, so look at this graph over here. Right now I've got it at the input of -1/2 radius length. We know that there's our sine curve. There's an infinite number of angles that puts you -1/2 radius length below the horizontal diameter. All these angles, so here, there's an angle here, there's an angle here, there's an angle here. So in order for it to be a function, what do we need? We need, for every vertical distance, we need just one angle. But in addition to that, we need to hit every single vertical distance at least once. So we need a range of angles that covers every vertical distance from -1 to 1 exactly once. We need a range of angles that covers every vertical distance from -1 to 1 but exactly once. Does it make sense? So, suggestions. So here's that summarized. In order for the reverse process of sine to be a function, we need one continuous interval of the angle such that every input from -1 maps exactly to 1 theta in the chosen interval. So we need some range of angles. So over here in this graph of sine, we're talking about some range of angles. So when we look at this sine graph now, and we think of the reverse process, it's like the input is the vertical axis, right? And the output is on the horizontal axis. So we need a range on the horizontal axis of angles. It's going to give us just one angle for every vertical distance from -1 to 1. Suggestions. What will work? Jad wants to give it a try.
Vertical rotation.
Okay, here. Good. So we're going to go from 0 to 2 pi. He wants this range of angles right there. Does it work? So let's look at this here. So we know the input. The input's the y coordinate. The output's the angle. No, I don't want that. Okay. So I'm looking at all the inputs from -1 to 1. And we're going to look at that range of angles from 0 to 2 pi. Do we get just one angle per input y coordinate in this range that he's chosen from 0 to 2 pi? Does it work? Does it work, Jed? So look over to the right. What's that? But what about right here? So right now I'm going to choose this y coordinate for the input. Do I get just one angle between 0 and 2 pi that corresponds to that y coordinate? No, you get two, right? You get an angle here, and you get an angle here. So 0 to 2 pi doesn't work. 0 to 2 pi, and it's the same thing with the negative vertical distances. Say I picked that right there. Sorry, something else here. So 0.2. If I pick 0.2, is there just one angle? No. There's two angles between 0 and 2 pi that give me this y coordinate of -0.2. So a new suggestion.
0 to pi over 2.
0 to pi over 2. So we're going to go from 0 to pi over 2, or this part of the graph. All right, does it give us just one angle for every y coordinate from -1 to 1? How about, does it give us just one angle, first of all? Does it give us one angle for every y coordinate from -1 to 1? No, what's missing? Yeah, so these down here. So you accomplished from 0 to pi over 2, you accomplished one output of an angle for every input, but we're not covering all the possible inputs, right? Because we got these negatives down here too that aren't covered in 0 to pi over 2. Yeah. Yeah. Okay, so she wants, I'll do it in red, she wants pi over 2 to 3 pi over 2. Does it give one angle for every y coordinate? Yes, this works. Do you see? So for any y coordinate that you pick, you get just one angle in that range from -pi over 2, or from pi over 2 to 3 pi over 2. It works. Okay, is there another way to do it? Matt?
Negative pi over 2 to pi over 2.
Negative pi over 2 to pi over 2. So we're going to go from here, I'll do it in black. Or I'll just finish in blue. All right, so that's part of what he did. So there's this. Does that do it? Negative pi over 2 to pi over 2. So for every one vertical distance, do you get just one angle? Is every vertical distance covered? Yes. Okay, so If it was one of these two, which would be more convenient? Let's talk about 0. So at a vertical distance of 0, let's just think about this vertical distance right here, 0. What would be a more logical choice? When the vertical distance is 0, what angle would make the most sense? 0 or pi? Doesn't 0 make the most sense? Like when the y coordinate is 0 or a vertical distance is 0, it kind of makes the most logical sense to think, okay, that's going to be when the angle is 0. And likewise, if we have if we have some positive y coordinate, oh, jeez, all over the place here. We have a positive y coordinate. What's logical is it would be this first angle that you'd come to, right, in the first quadrant. Okay, so that's what mathematicians have decided, that we're going to choose from negative pi over 2 to pi over 2 to be the range, because that hits every y coordinate from -1 to 1 and hits them only once with one angle. So then our input is, it's the angle, still the angle swept counterclockwise from 3 o'clock, but then here, what are those angles? What are those angle measures? We're sweeping clockwise. So those angle measures are negative. So the range of angles from negative pi over 2, or clockwise from 3 o'clock, to positive pi over 2, gives us exactly one output angle for every input y coordinate. This is really important that you understand this. So, the inverse function is called the arc sine or the inverse sine. Down here at the bottom, it's called the arc sine or the inverse sine. And there's two common ways to express it. Written out arc sine like this, or with the -1. Again, that's not an exponent. It doesn't mean 1 over sine x. That means the reverse process of sine. You input the vertical distance as a fraction of a radius length. It outputs the angle measure swept counterclockwise. So I want you to, as a little quiz here, to see if you're getting it, write it out without any help. What's the domain? What are all possible input values of the arc sine? And what's the range? This is crucial for understanding this. It's really having down pat. What is the domain? What are all possible inputs? What's the range? What are all possible input values? All possible input values. Benji, all possible input values into arc sine. What are they? Negative pi over 2 to pi over 2. What do you think? Is it right? He agrees? Yes? Margarita, you disagree? What do you think it should be? -1 to 1. Which is it? -1 to 1. The input is the vertical distance above the horizontal diameter as a fraction of a radius, because it's the reverse of sine. It's the reverse process. So we're talking about all possible will be lowest is -1, up to the highest is 1. What's the range? We have to restrict angles, right? So our input into sine is any possible angle, all real numbers. We can go around as many times as we want, counterclockwise or clockwise. But in order to have a function, we have to restrict the angles of the reverse process. To have a function, we have to restrict the angle to negative pi over 2 to pi over 2. Or else we don't have a function, right? We get many, many angles for the same vertical distance. To make it a function, we need just one angle for every vertical distance. And so by picking the range negative pi over 2 to pi over 2, it hits every, we get just one angle hitting every possible vertical distance from -1 to 1. Does that make sense? It's really important. Okay, so now I got a bunch of practice problems here. So what's the arc sine of the sine of 3 pi over 4? 3 pi over 4, right? Remember our example from the beginning of class? Where's 3 pi over 4?
It's on the second quadrant.
It's in the second quadrant. An angle of 3 pi over 4 is what? Right here, exactly. Splitting the second quadrant in half. So what's the sine of 3 pi over 4? That's the kind of the first thing we look at here. What's the sine of 3 pi over 4? Root 2 over 2. Let's show that. So there's the sine, is this vertical distance, root 2 over 2. What's the inverse sine of root 2 over 2? Is it 3 pi over 4? So this is what this is saying now. Right here, this is root 2 over 2. So now we're asking, what's the arc sine of radical 2 over 2? It has to be in the range of what angles? From what to what? Negative pi over 2 to pi over 2. So which angle? There's one angle between negative pi over 2 and pi over 2 that gives us a vertical height of radical 2 over 2, which is what? It's this angle right here. See? It's this angle right here to get us this spot on the circle, which is? Please know this. Pi over 4. So the answer to this is not 3 pi over 4 because of this restriction on the angles. When you do the arc sine, it has to be pi over 4. Okay, so do these exercises, but there's no calculator on this, on any of these. Write exact answers without using your calculator for all of them. So take 5 minutes, work together, we'll walk around and help. These are really good problems to see if you understand arc sine. Okay? You have to know your unit circle for your quiz, too. You got to remember that stuff. No calculator.
Well, it's fine.
But from what to what?
Yeah.
You guys are right idea, but get a degree measure between negative 90 and No calculator. Figure it out. You can write an expression, give an exact answer with an expression. No calculator.
So I guess the place is to figure out where we need to fire over to, so you can have the same. So that's right, so I'll figure out.
Okay, so what's the sine of 5 pi over 3? I'm showing it there. The sine of 5 pi over 3 is what? Do you remember? Square root of 3 over 2. Is that right? Square root of 3 over 2. Not quite. Negative. From your unit circle that you did for your quiz. So that's the picture I'm showing there. That the sine of 5 pi over 3 is negative radical 3 over 2. We're going to put negative radical 3 over 2 into arc sine. Are we going to get 5 pi over 3? No. We're going to get an angle between negative pi over 2 and pi over 2. That angle that has the same y-coordinate, or has the y-coordinate of negative radical 3 over 2. It's going to be this, so I'm showing it right here. Here's the angle it's going to be. I'm showing it right here. Output angle theta, it's going to be this angle right here. What angle is that? Negative pi over 3. Do you know what's going on? Does it make sense? This is hard. What? Because the output of arc sine has to be an angle between negative pi over 2 and pi over 2. Those are the outputs of arc sine, from negative pi over 2 to pi over 2. So if our y-coordinate is negative radical 3 over 2, it's the one angle between negative pi over 2 and pi over 2 that gets us that y-coordinate, right there. There's the y-coordinate. It has to be that angle between negative pi over 2 and pi over 2. Is it better? Okay, let's try 7 pi over 6. What is the sine of 7 pi over 6? So let's draw that. Here we go. Let's try it. So 7 pi over 6 is this angle right here. What's the sine of 7 pi over 6, first of all? It puts us at this point at the circle, which gives us a sine of negative 1/2. So this right here, sine of 7 pi over 6 is negative 1/2. So now we're doing the arc sine of negative 1/2. What angle between negative pi over 2 and pi over 2 gives us a vertical distance of negative 1/2? No, 11 pi over 6 is not in that range. It's got to be between negative pi over 2 and pi over 2. Negative pi over 6. It's showing you right here. It's showing you right here. that the output is going to be this angle right here to get us that y coordinate. So negative pi over 6. Is this starting to make sense?
Yes.
Okay. Requests from the last ones there. So let's do some of these harder ones here. Sine of 6. Let's do this. How about this one? Arcsine of sine of 251. Where is 251 degrees? Third quadrant? Toward the beginning of it or toward the end of it? Toward the end. It's almost 270, right? 270 is at the bottom. So 251 is something like this. I'll just guess it's like that, okay? So here's an angle of 251 degrees. The sine of it is some number close to -1, right? So now we're going to take the arc sine of whatever that is. What angle will it give us? So can you see a visual representation of the angle we'll get when we take the arc sine of this y coordinate corresponding to 251 degrees down here? No. What's that? It's going to be this negative angle right here. This negative angle right here is going to give us the same y coordinate as the sine of 251. So how can we find what that angle is? By symmetry in the circle, how can we find what that angle is?
So the same answer
Yeah.
Okay, so 251 is 19 degrees away from 270,
Okay.
and that other output is the full thing would be 90, so you can do 90 minus 19.
So this would be 19 also.
Yeah.
So you must do 90 minus 19 to get this angle right here.
Yeah, and that's negative 71.
Negative 71 degrees gives us, did you say that? Okay. I'm not into just answers without the thought process, so that's why I probably didn't respond to that. Okay. How else could you have gotten that negative 71? Yeah.
If you were to follow through with the 251 degrees, you would end up on 4 pi over 3, and then the same.
No, no, it's not 4 pi over. Maybe it's close. It's not 4 pi over 3. There's lots more angles than just the 16 key angles. I warned you about this. Don't, if you see a point on the circle, don't think it's necessarily one of the 16 key angles. But anyway, go ahead. Sorry. Just be careful. So, is that you were gonna just work? Yeah, no, don't do that. Maybe it's close, but don't assume because it's somewhere close to 4 pi over 3. It's got to be 4 pi over 3. Okay? Yeah. Right. So we could take this right here. Right. So this angle right here is going to be the same as the angle we want. So how would you get that? 251 minus 180, and that will also get you 71, and then you know it's going to be negative 71. Okay, so let me show you why this is so important. We're taking so much time to figure this out and get this here. Let me show you with one example. Okay, so say the radius of this fan is 2.3 feet. Okay, and we're interested in, so what angle measure Has the ladybug swept? When reaching, say, 0.5 feet above the horizontal diameter for the second time. So as it sweeps, it starts here at 0. It starts sweeping counterclockwise. Right around here, it reaches 0.5 feet for the first time. But then it hits that height, 0.5 feet, a second time, somewhere over here. There we go. So this right here is 0.5 feet. What angle is this right here? So you really have to know what's going on with arc sine to figure this out. So what angle in degrees is that? So we're out of time, but I'll talk through it quickly. So first of all, what's the input into arc sine? Vertical distance. Is it 0.5? Do we put 0.5 in here? No, that's feet. What's the input? It's in fraction of a radius. So we need to put in 0.5 divided by 2.3 to get what fraction of a radius 0.5 is. So the input is not 0.5, but 0.5 divided by 2.3. Okay? So let's do this in degrees. Set your calculator for degrees and find that right there. And what do you got? Are you going to get the answer, first of all? No, because the angle is going to be, that you're going to get, is going to be between negative 90 and 90 degrees. What'd you get? 12.56? So you have to know what that number means. I want this angle. So what angle did you just get? You got the angle in the first quadrant that gives you that same height. So you're going to take, so this angle right here is 12.56. So you're going to subtract that from 180 to get the angle. Theta equals 180 minus 12.56, 167.44 degrees is this angle, the red one here. So when you use arc sine in your calculator, you have to know what's going on.